Welcome to the 40 Summit 2018. I hope everybody's enjoying their time here. This session is about determining minimum system requirements. So I'm Tim Penner. I'm Senior Technical Services Engineer for 40 Inc. in the US. I've worked there since 2006, so almost 12 years. In December, it'll be 12 years. I handle IT as well as most of the technical, not most of the technical stuff, but I mean, I handle technical support in cases and IT stuff. So anyways, that's my background. What resources does my application need? I mean, that's the main question. I think that's why everybody's here. And I mean, I'm kind of curious. I mean, does anybody actually have any rhyme or reason of how they're currently figuring that out? Pretty much just taking the data size and saying that's how much memory you need. Well, that's why we're here. So awesome, glad to hear that. It's pretty simple, actually. There's just a couple rules to follow to begin with for determining how much memory your application needs. And the rules are actually very simple. There's only like 4 rules or something like that. But like the first rule is basically the ratio of cache to memory. It's important that when you're coming up with a baseline suggestion, which I'll go further in a little while about what comes after the baseline, but when you're coming up with your baseline suggestion, it's important to think of the total memory that's actually on the system, and you want to think of the ratio of the cache that you're setting for your database to the overall memory that's on the system. It's important that at the get-go you do not exceed 50% of RAM, well, at least not without monitoring. The reason for this is that, I mean, obviously memory is faster than a hard drive. That's why you want to set your cache size. That's why you want to load the data into memory. But if you go past 50%, what tends to happen is the operating system might end up needing to use some memory. And what can happen is that you might end up entering into a situation where you actually will start to page stuff out from memory to disk. One way to think of this is that if you're already thinking of using 50% of the available memory, you probably have a really large data file or a really large index file. Well, if the operating system decided to just place that into its own memory, that might, put the overall used memory of the system really high. And you might enter into a situation where it's actually paging to disk. And paging to disk hurts performance because it goes back to disk. And there's additional overhead of trying to figure out what can be brought out of memory and writing to disk and reading from disk. So that's kind of the first rule there. The second rule is about automatic cache purges. So automatic cache purges, basically the way that this comes in is when you've set your cache size to any certain value, let's just say you've set your cache size to 10 gigabytes, what happens is when your used cache reaches or approaches 10 gigabytes, what will happen is there will be an automatic cache purge. It used to be 25% of the memory that would be purged, but I believe now as of V16, it's about 10% of memory. So basically, that happens automatic. It's perfectly normal. However, you want to keep an eye on how many times it happens. I like to ask or suggest that people aim for about 6 automatic cache purges per day. It's just a happy medium that I've found that sort of works good. It's not too many, it's not too little. The thing is that if you have too many cache purges in a single day, where you're loading the amount of used cache all the way to 100%, and then you're purging memory, and then loading it back up and purging, and loading up and purging, you get into a situation that is considered cache thrashing. And it's technically, I mean, it's not something you want to do because it's hurting performance, because it's constantly flushing and purging, and it's just not a good thing. So you might be able to go with a few more times than that, maybe a few less, but I just found that 6 is a good happy medium to kind of aim for. So another rule that I like to suggest to follow is I like to remind people that free memory is good. So low free memory is bad and can cause paging. Now, I've had a lot of conversations with people about this, and it's kind of interesting because a lot of people tend to think that free memory is bad, and that if I have free memory that's sitting there, let's say I have 16 gigs of memory and I'm only using 8, 8 gigs is unused. It's unused. That's bad. Well, sure, from that point of view, but if you're using 100% of your memory because your operating system is doing other things or you've done other things, and then 4D requests additional memory, what's going to happen? The free memory that 4D is requesting needs to come from somewhere. So what's going to happen is the operating system is going to say, oh, we don't have free memory for you, so we need to figure out what can we page to disk. Paging to disk is a performance hit. It will slow things down. So, I mean, you could say, yeah, free memory. I don't want to have free memory. I want to make sure that my system is using it all. But then you got to remember it's going to have a performance hit when you need free memory. So I suggest making sure that you always have at least a gig of free memory. I mean, more memory is okay, but just if you get under a gig of, if you get under a gigabyte of free memory available on a system, that's kind of a danger zone, and it's kind of signifying that, hey, you might want to add additional memory to the overall system or adjust your overall settings to account for that, because you don't want to page. So with that said, the next rule is really core consideration. This might be kind of a newer concept for most of us, I think, but basically it's just to remember to consider the number of cores that are actually going to be needed. For example, maybe you're using the web server, and the web server can actually run preemptively for like static pages, and if you're using v16 and you actually enable the preemptive web server, that means it can actually run on its own core. The SQL server also can run on a separate core, or SQL request can run on a separate core. If you're actually using the preemptive workers or preemptive processes, those can all run on additional cores. So, I mean, let's just say you've got 8 workers that are all preemptive workers. You're running the SQL server, you're running the web server. Dual core machine might not be good enough. So just keep that in mind. You gotta remember which services you've enabled, which services can use additional cores, and how many cores you've actually assigned to your either virtual machine or to your physical machine. Assigned is more of a virtual concept, but either way, same thing. With that said, so how can we actually determine a baseline? So for determining a baseline suggestion of what you would think that an application might need, you just need to really take in a couple different metrics, a couple different pieces of data points. So the first one would be the size of the data file. The next one would be the size of the index file. I mean, this is pretty straightforward right here. You would just kind of combine those values together to get an idea of how much data your application might need to load into memory. There may be some variance to this. There might be some selectivity that you're not actually loading into memory. For example, maybe you have a table that is really historically, it's just for historical data. Maybe you're not actually querying on that, so it's technically not getting loaded into memory. Maybe you can determine how much data that is. So that's something that you might be able to exclude, but in general, the size of the data file and the size of the index file are important metrics to use. Beyond that, you do want to also look at the total number of processes. I'm talking about stored procedures, client processes, workers, and at this point I'm actually referring to the amount of memory that is consumed by those. So I mean, I mentioned workers, but at this point I'm just referring to the amount of memory that is used by those. Because each process typically uses about 1 megabyte. I mean, that's the typical stack space that I would suggest to use. I think if you allow the automatic stack size, which is setting the stack size to 0 in your new process command, I think it's probably about 768, but still, I like to suggest that people use 1 megabyte just as a general rule. So, I mean, if you've got 100 client processes, 10 stored procedures, and a couple workers, I mean, a megabyte per one is something to consider there. Another one is whether or not the web server is enabled. I already mentioned that the web server can actually use an additional core on its own, and you might have preemptive web serving enabled in v16. So that can tie back into the core consideration, as well as how many concurrent connections you have, like how many concurrent sessions you have enabled. If you have like session management enabled, This is important because not only for the core consideration, but each of those sessions would consume memory. Again, I like to think of it as 1 megabyte, typically 1 megabyte per session per concurrent connection. So I mean, if you have 10 concurrent sessions, that's only 10 megs. But if you have 1,000, that's a gigabyte right there. So it's something to keep in mind. I believe our concurrent connection setting allows you to set it all the way up to 32,000, which would be 32 gigs if you actually got all the way up to 32,000 connections. I mean, you technically could set the timeout to unlimited, set your max thing to that. So yeah, you could theoretically get to that. So keep that in mind as far as, you know, the amount of memory and cores that are used for your web server. Another one very similar is the SQL Server. As I mentioned, it can also run preemptively, and then you've also got to worry about how many concurrent connections there are there. I don't have the exact figure of memory that's required by the SQL Server. I'm sorry for that. But it does require additional memory per connection. Again, I'd just like to factor in about 1 megabyte per connection. I think it's a safe number to factor in here. So beyond that, preemptive processes or workers. This, as I already mentioned up there, the total number of processes for memory, this last one is more for the core consideration. Because if you're running preemptive new processes and you're running workers, I mean, again, like I said, if you've got 10 different preemptive processes, you're probably not going to want to run on a dual core machine because that's just not going to really take advantage of any preemptive processing. You've really only got 2 cores. So with all that, yeah, how many? So with all that, let's just run through a quick example here. I mean, let's just say that you've got a 10 gigabyte data file. And maybe you've got a 2.5 gigabyte index file. And maybe you've got 600, let's just say 10 processes per client with 60 clients, okay? So that's where I come up with the 600 processes. Maybe some of those are stored procedures. Maybe you have fewer clients or more clients and more processes. But just in general, let's just say that this server has 600 processes. The web server is, yes, enabled with 1,000 concurrent connections. And yeah, we've got 25 concurrent connections to the SQL Server, but no preemptive processes. So how would you figure out what that would require? I mean, get out a calculator and just start typing in numbers. Well, luckily, I do have an example. So I have an example on the baseline suggestion. Let me quickly exit out of my Keynote and give you guys this demo. Just a moment. Close that. I'm just going to mirror so I don't have to stare over there. And okay. So let's see here. Open. So this calculator here, it should exist on your USB key. Let me just hide this so that it's a little bit. There we go. So this is my calculator. UI looks very basic. I'm not in UI design. Had I had Ad design this, it would have looked beautiful. But no, I designed it. So anyways, I think we said that, let's just plug in those numbers that we had just looked at. Let's say that we have a 10 gigabyte data file and a 2.5 gig index file. So combined, that's 12.5 gigs. However, you know, I mentioned ratio of selectivity, or I think I mentioned that. So let's just say that, you know, we're actually utilizing about 80% of the data, where we think that maybe 20% of this data we're actually not querying upon. It's just historical data that's being written to and technically not really active. Maybe you've got 100% selectivity, but just for this rough calculation, we're going to say it's at 80%. So stored procedures, I think, so let's just say we've got 20 stored procedures and 580 client processes. That'll get us up to our 600 number that I had on that previous slide. I think I said no preemptive processes, and for web processes, I think I said 1,000, and for SQL connections, I think I said 25. So with that, just rough calculation, baseline calculation, I mean, this calculator is suggesting that you use a 4-core, a 4-CPU machine. With the machine should have at least 21.586 gigabytes of RAM. Obviously, you want to go a little bit more than that. You can't get exactly that number. And a cache size of about 10 gigabytes. That's what you would actually set to your cache size for this database. This is just a baseline suggestion based on the metrics that we've entered. I mean, we can change this to 100% selectivity, and we can now see that we're being suggested to have 26 gigs of memory on the machine with 12.5 gigs set as the cache size. I mean, technically, that cache size is 100% of our data file and index. So, I mean, that might be overkill. But again, this is just a baseline suggestion. We could throw in some workers. Let's just say we threw in 5 workers. Well, now we need 9 CPU cores, if you want to take advantage of the preemptiveness of the workers, that is. You can mess with all these numbers, and it's just going to keep calculating it out based on the metrics that I've already described. So I like to think that this is a really nice way to get a baseline suggestion, but really, I think the question here is, what do we do next? What do we do after the baseline suggestion? Just a moment, let me turn off my mirroring so I can get back to my presenter mode here. Display, arrangement, turn off mirroring. There we go. So, we just ran through that. So what next? We've got this baseline suggestion. We can give somebody a suggestion. We can give reason for why that suggestion is our suggestion. We have metrics to back up that suggestion. But really, what do we do next? Well, next is fine-tuning. We need to understand during runtime whether or not our baseline suggestion is actually valid. Maybe it's a little over, maybe it's a little less. And so what do we do to fine-tune? Well, technically, we just use the information component. You could probably roll your own way of gathering these metrics and reviewing it, but I use the information component because it's already built, does the graphs for you and everything. So we use the information component, we install it on the machine, we gather logs during normal usage. And then after we've gathered the logs with the normal usage, we parse the logs into a graph. And then we compare, sorry, I went one slide to me, I should have just left it there. So we compare the baseline suggestion against the actual usage. And after we have that, we fine-tune the suggestions based on the observed usage. So for this, I actually have another example that I'd like to run through here. So let me see here. Let me just exit out again. And I'll just run it like this time. Hold on. So this example, I wanted to show you guys what I mean by installing the information component and gathering those logs. Has anybody here used the information component? So a few, maybe very, very few. It's a great tool. I love this tool, I really do. It's the first line of defense that us in tech support ask people to install because it gathers so much information. It's a very useful thing. We actually suggest that you have it installed on your applications before you have an issue. I mean, whenever we get a case, we ask people to install it, but it's so helpful. The logs are very small, probably about 12 kilobyte per log, and they're gathered every 5 minutes. So about 6 weeks worth of logs, logged every 5 minutes, is only about 1/4 of a gigabyte, 250 megs. It's very small. But the amount of information that you get from that is very large and very useful. So I wanted to show everybody where to get that and how to install it. So first off, to obtain the information component, the easiest place to go is actually to partnercentral.40.com. On partnercentral.40.com, once you log in here, on the left, there will be a little area that underneath your account rep, it'll show a link right here to download the information component. So this is the easiest entry point to download it. Clicking on this will bring you over to the download page on Tau. You could also go directly to Tau to download it, but the navigation into it, not as straightforward. So once you're here, you just scroll down to the bottom and the information component is available for the current versions, 17, 16, and 15. We also have archives for version 14, 13, and version 12 here. So it is still available for those older versions. So I'm just going to download version 16, just because I've been running version 16 still. So now I have it. And let's see, we're just going to extract this like that. And now we've got the component. So let me just copy this and hide that for a second. Come over here and let's just create a brand new database. Very straightforward. And I'm just going to say new sample. Okay. So now that I've done that, what I'm going to do, my shortcut to get into the folder is show on disk, get 40 folder. And then I'll just go into the data folder. All right, there we go. So here's where I saved it. Let me just get into the package contents here for a moment. So I'll need to create a new folder called components. And I did not mean to have that capitalized. Hold on. And I did not mean to misspell that. All right, I think I spelled that right now. And I've just pasted in the 40 information component that I've just downloaded. Very straightforward. So it's not actually going to be available yet because I need to restart the database for it to show up. But yeah, component methods, yeah, no, not going to show up. I didn't expect it to. Just thought I'd check though. So we'll reopen the new sample. And now under component, we should have the 40 info report down here at the bottom. So how do we actually complete the installation? Because that's just part of it, which actually that would be the bare minimum of what would be suggested to just have it installed and available. So that way, if some problem happens later on, sorry, I'm kind of going on a tangent here, away from the baseline suggestion, but our general suggestion is to always have the information component installed, and that is the basic installation method without actually running it. And the reason why that would be important is that if a problem happens later on, you can always enable the logging at any point in time without having to restart your database. Getting back to the baseline suggestion though, sorry for getting off topic there. To complete the installation process of making it actually usable, we would want to create two methods. The first is a shared method that allows us to get the additional information from like get database parameter. The component itself can't directly call get database parameter to understand like what the remote timeout mode or remote timeout setting is. So we set up the shared database right here, the shared database method with this name that is set to be shared between the component and the database, and that would allow the information component to obtain that information that it can't directly obtain on its own. So that's the first step. The next step is to put in the actual call that runs it. If you're running the information component on 40 server, I did not mean to click that. If you're running it on 40 server, you could take advantage of a stored procedure that we already have. So basically, let me just come back over into the database settings and go into on server startup. So this is the method that is just available right on the Tau download page for installing the information component. What this method does is it first checks to see whether or not, well, it gets a component list. It gets a list of all of the components that are installed on the system. And then it checks to make sure that the 40 information component is actually installed on this system. So this code can actually be left in place if you wanted to, and you could remove and re-add the information component as needed, but you'd need to restart the database. Because this code, if the information component's not found, this code won't do anything. That's why we're using execute method. We're not just writing the method right out. So again, this code right here, this entry method allows you to just remove the component, put it back in whenever you need, restart the database, and then you could start the logging automatically. The suggested code will start a log every 5 minutes. That's sufficient for most use cases. And again, like I said, it only creates about a 12 kilobyte log file on that interval. The actual creation of the log takes probably less than a second. Within each log, it would actually tell you the exact amount of time it took to create the log. It's usually just a couple hundred milliseconds. So I mean, it's a very small performance hit. There's really no performance hit that I'm aware of because the amount of CPU usage is only a couple hundred milliseconds every 5 minutes. And the amount of storage on disk is very small. So in either case, this is the code that you would put on startup. This will allow you to create a log every 5 minutes automatically, and it'll be placed into the folder reports directory, which is located next to your data file. You would want to do this in the system that you've just set up your baseline suggestions for. And then you would want to run this for some period of time during normal usage, at least a day, maybe a couple days, so that you can really understand how the usage is. And then what we can do is we can analyze those folder reports. I have some folder reports here on my system that I plan to analyze. I just need to quickly look at this. Yeah, that's basically the next thing I was going to do. So the same component, the information component that we just installed to gather the logs, that same component can also be used to parse the logs. So everybody here that has access to the information component also has access to parse these logs. So the method for that, I'm just going to go back into, actually I'll do it this way. So the one that I always use is this compare display method, the AA4D NP report compare display. Just for the naming convention, the NP basically says it's going to be in a new process. So what this allows you to do is it brings up this. And from here, we can select a folder. And let me just quickly locate my sample reports here. So, so for example, here's a report, folder report from one of our systems that, that I've gathered. Now, here are all the reports that have been parsed. I think it was a couple thousand reports that it just parsed, and it went fairly quickly. We can click on this graph button right here, and this graph button brings up this nice graph. So there's various pieces of information here that are being displayed, but the main thing that I want to point out here is that the amount of cache is, does this thing even work? Never mind. My laser pointer doesn't work. So this line right up here at the very top, that is your set cache size. And if you see this darker green line right here, that's the used cache size. So if you notice here, there's not a single purge. The used cache here never actually even reaches 100%. So there's absolutely no purge that's going on here. I think we have the cache set, by the way, the minimum report, the one to the left is on the 1st. The one to the right is on the 13th of February. So this is 13 days of running, and there's not a single purge. So to me, this is an unnecessarily high cache setting. This is obviously somewhere where, I mean, they just set it too high. It's unnecessary. Let me see here. I have another report here that I wanted to show. Yes. So here is a different set. You could probably tell from the name of the folder. This is a test database I was running to test something. And if you look here, this is a period of 2 days. So from the 21st to the 23rd. And it's really hard to see what's going on here. So let me zoom in a bit. Okay, so here we've zoomed in. And so now we're looking at a period of what, like 3 hours? from the 21st, on the 20th and the 21st, from 11 to 14. Yeah, I'm having a little trouble doing math, but I want to say that's about 3 hours. So if you look here, there's a lot of cache purges going on here. And if you also notice, you might see that the amount, the spacing in between these vertical lines, there's some variance there. Well, basically what's going on here is I had set it to take a report every 5 minutes. But because of the amount of cache thrashing that was going on, because that's really what's going on here. Your cache is too low. The amount of used cache is hitting it. It's purging 10%, and then it's filling back up, and it's purging 10%, and it's filling back up, and it's purging 10%. And it's just thrashing. So that's caused a performance hit. And you can see that the actual stored procedure that's supposed to be running every 5 minutes is technically not running every 5 minutes. It's running on an alternate schedule because it can't run at its normal time. It's just... So cache thrashing can cause performance fluctuations, for lack of a better term. In this situation, we would definitely want to increase the cache size here. But however, if we look at the, let's see, there's supposed to be, hold on. Let me just double click on one of these lines. That'll bring up an actual report. So I can see here that the total amount of memory that's available on the system is 98 gigs. And if I remember correctly, the cache size set was 64 gigs. So I'm above the 50% mark, and I still need more memory. I still need more cache. So obviously this database, this machine needs more memory to do the operations that it's trying to do. One of the other things that I wanted to show you that's on this graph here is we can cycle through a couple different pieces of information. Let me just zoom back in. So this attention button, it's actually lit up. If the attention button is grayed out, that's good. That means that there's no attention items that have been found in any of your reports. But if that attention item is lit up, the button is lit up like that, we need to click it. And if we click it a second time, we can get a little bit more information right here. So you can see here that there's a bunch of temp sort files that are being listed as being created. And then it goes down, and then it comes back up, and there's a bunch of more temporary sort files. Well, these temp sort files, they're created in the situation where you're trying to sort something, you're trying to do an order by, and there's not enough room in cache to place that. So if you have these files on your machine, that in itself means that you need more cache. So this is the process of fine-tuning that I'm referring to. We need to gather information. We need to double-check our baseline suggestion and determine, was it too high, was it too low? I mean, technically, you could even start with this. But this is kind of where, what suggestion are you going to give them to start with? I mean, you've got to start somewhere. So I think the baseline suggestion is a good start. There's a scientific reason to why you're giving that baseline suggestion, but this is really, I guess, more of the scientific approach because we're actually testing and making observations and making changes based on that. So in either case, this would be cache thrashing. So another thing that I should point out here real quick is that we can actually also hold shift and click on this update SVG button, and it kind of toggles through a couple other pieces of information. One of those pieces of information here is the used virtual memory. Now, I'm not sure if I made it clear earlier, but there's a concept of paging things to disk. 4D is only going to be able to allocate, actually that sentence started off wrong. Any application can have so much memory associated to it. Some of that memory that's associated to it is going to be real memory. Some of it might be virtual memory that's paged to disk. In 4D, we consider all of our memory virtual memory, and then you could subtract the real memory to really figure out what's been paged to disk. In this situation, this dark gray line right here is referenced right here as the used RAM. So this is the actual physical RAM that's being used by this application right now. However, this, I want to say teal line at the top, is the used virtual memory. So the delta that's in between here is the amount of memory that's kind of been swapped to disk. So if you look right here, you can see at the top the maximum and minimum numbers that have been observed throughout the visible reports. So the minimum number of used RAM and the max is about 74 gigs. and the used virtual memory is about 94. So that's about 20 gigs of memory that has been swapped to disk. Obviously, disk is slower than RAM. So all of this combined is telling me that this machine is suffering a performance hit. It could definitely benefit from having more memory physically installed and a higher cache. I hope that's clear to everybody from looking at that. Let me pull up another report. This one's more just for fun. I heard from the Paris Summit that there was a request to see this other situation. Again, if you're looking at the names of the folders, it's clear what's going on here. So let me look at the graph. Seems a little odd. Let me cycle through and look at the used virtual memory there. It just keeps going up and up and up. It never goes down. Let me see what's the attention item. Okay, so the attention item here, the free memory got really low. This is a memory leak. This is a clear memory leak. I actually caused it myself. I ran a loop, I called new list, and I never called clear list. I hope you guys saw the best practices session yesterday, the one from Vance about best practices for coding, defensive programming. I'm sorry. He should have covered this sort of situation. You know, you can cause this situation by calling DOM parse XML and never calling clear XML or the XML command to close the file. There's other commands that create references, and you need to clear those references later on. And if you don't, you are leaking memory. So that is another piece of information that can be obtained from these information components. So the information component wasn't really supposed to be the main focus of this session, but it's such a useful tool that I am such an advocate for. I just had to show you guys more usefulnesses of it. So again, this is a memory leak. And yeah, I think we got up to about 109 gigs of used virtual memory here before I finally said, okay, that's enough, I'll quit. So yeah, that's something else you would want to look out for. Let me see here. Let me just go back to my slides here. I'm going to need to turn off mirroring. So that was kind of our fine-tuning examples, okay? I mean, you'd want to take your observations and observe and understand, you know, do I need to increase the memory, or did I set too much memory and, you know, technically we could lower it? I mean, if you've requested more memory from your IT department and they've given it to you, great. You might as well leave that. You might not want to tell them, just saying. But you know, you've got room for growth there. But some of the things that we tried to look at here, we tried to look at cache thrashing to understand, you know, what it looks like when your machine has too low of cache, and what you would need to do for that. We also looked at the amount of swapped memory that is that's actually there. In this screenshot here, we have about 20 gigabytes of swapped memory. That, you know, I mean that's memory that's page to disk. That, you know, anytime 4D needs to access that memory again, it's going to need to read it back from disk, which it might as well not even be in memory. So you would need more memory to really take advantage of, to prevent that performance hit. Yeah, there's the swapped memory right there. We also looked at unnecessarily high cache. You know, just, I mean, this situation here, I mean, it's not necessarily bad per se. It's just that with the unnecessarily high cache, it's not really what 4D is designed for. The 4D cache mechanism was redesigned back in version 12 and again in version 16. But I believe in both situations, it's not designed to never purge. Purging is a perfectly normal operation that the cache system is designed to do. So again, it's not necessarily bad to have it too high. It's just unnecessary. Beyond that, I definitely need to mention an honorable mention here for your speed of your hard drives. I couldn't really factor this into determining minimum requirements, But it's very important that everybody understand that an SSD is the fastest that you're going to get. If you have a spindle-based hard drive, any of this loading from your hard drive into memory is going to be slower. Anytime anything gets paged to disk, it's going to be slower. An SSD is the best performance that you're going to be able to achieve. So if you're not running an SSD right now, I mean, that's really something you need to consider doing. Again, I couldn't really figure out how to factor that into minimum requirements, but it's definitely something to keep in mind. I mean, I would consider it a minimum requirement. It's just not really a metric. Well, you could run some disk benchmarks. This is actually bringing me to the close of my presentation. Beyond that, I'd like to ask if anybody has any questions for me that I can answer.
Hey, Tim, nice job. How does running 32-bit versus 64-bit apply to server-side
Great question.
Size?
Great question. Running 32-bit, it is typically said that 64-bit processes would require approximately double the amount of memory, but that's the least of your problems. If you're running 32-bit, then your maximum amount of memory, overall, used virtual memory that your system can allocate is 4 gigabytes. You're shooting yourself in the foot. Don't run 32-bit. Our 32-bit server is only available for compatibility reasons. We actually don't certify it at all. We don't suggest that you run 32-bit because it's got a 4 gig memory limit. And I mean, honestly, if you're on Mac, the application 4D is going to use about a gig of memory just by itself in memory when you run it. And if you've set your cache to 2.5 gigs, you're now up to 3.5. You're 500 megabytes away from the mark of once you hit 4 gigs, your application will crash or freeze. That is expected. It's not a bug. The bug is that you're going beyond 4 gigs, and that's not something we can address. That's something that your code would need to be addressed. Because I don't think I mentioned earlier, but in addition to stack size for each process, there's also additional memory it could use, which we can't really calculate up front. What I mean by that is, if you parse XML, you load XML into memory, that's not going to go into the cache. It's not going to go into the stack size. It's going to go into additional memory that is used by 4D. If you're loading blobs or loading pictures, or you've got pictures on your form, all of that is going to be loading into memory that is beyond that. So that's something that we can't really calculate, but you might have a bit of a better understanding for what you're using.
Well, and actually, I'm glad you touched on that, because the other thing I was curious about is how the stack size that we assign when we call something like new process or execute on the server, how does that relate to that 1 megabyte rule of thumb metric? Does it?
What do you mean? How does it relate to that?
Well, I guess I'm wondering, when would I ever not want to use the 4D 0 standard?
Honestly, 0 is the best thing to use. Okay. Honestly, I'm sorry if I gave the wrong impression. I suggest that you account for 1 megabyte, but honestly, 0 is the best setting to use, because on 32-bit and 64-bit, setting a stack size in the new process command to 0 might be slightly different. And when we go to the next version, 17, go to 18, if the 4D recommendation changes, 0 in your code will change with us. Our recommendation, our default settings per se for the stack size will continue to change as long as you're using 0 as your stack size.
So given that, when would I ever even need to change that to something else?
You probably wouldn't, unless you're really trying to, if you have a process that's used very lightly and there's very small amount of things that it's doing, you might be able to squeeze some additional headroom out of that by lowering the stack size below what it's already at, below the default value. I don't really see that much of a value in doing that, because your programming time is expensive and RAM is cheap. So it's probably better. That was actually a quote from somebody in the audience earlier. But so it would be better to just leave it at 0, and if you think you need more memory, to increase it.
So and I hate to keep hitting on this, but I think, especially for longtime guys like me, we just have this sense in the back of our mind that more memory is always better, and I'm really going to create a problem if I don't give a new process enough memory.
Yeah.
And I just am looking to be reassured that zero thing is going to cover me on, on even big stuff that's using a lot of resources.
I can give you a quick example. So I know for a fact that we had an issue a number of years back where web area was on a form, and it was a case I had, but the web area, the form, was opened with new process, and it was set to something like 64 kilobytes for the stack size. Really small, 64 times 1024. And the web area just wouldn't work right. The solution was to increase the stack size. What we ended up having to do was just set it to 0, worked fine. Set it to 1 meg, worked fine. There might have been another number in there, but I mean, with 64 KB, it was just too small of a stack size, and it just couldn't work. Does that answer all of your questions?
Yeah, it does.
Okay.
Hi, Tim. Thanks. I just have one comment about too much memory is never going to cause you problems. That's really not true. If you have, for example, in your server, and you say, I'm going to flush memory every 30 minutes, and you have too much cache there, you will basically halt the server while that's flushing.
Yeah, so there's a couple things with what you just said. First off, the flush buffers interval should be set to 20 seconds. The default interval for flush buffers was changed to 20 seconds back in version 12. Actually, it was changed in version 11 during the cache optimizations, but in version 11, you could only set your flush buffers to 1-minute intervals, even though our recommendation was to use flush buffers on a 20-second interval. So in version 12, we updated our database settings to include a seconds interval. So if your database settings is still set to 30 minutes, because back in 2004, it was 15 minutes was the default. But there was a tech note in version 11 by Josh Fletcher about the cache optimizations. And that explains that 20 seconds, our cache system is designed for more frequent flushes of smaller sizes. And you're absolutely right that if you flush after 30 minutes, that's a huge amount of data that needs to flush. But that's not really what I was trying to describe earlier by saying having a lot of free memory is not a problem. What you're describing is having a lot of memory, a lot of data, a lot of changes that have not yet been flushed to disk because your flush buffers interval is set to 30 minutes. That's 30 minutes worth of changes to the data file that's just sitting in memory. I mean, yeah, you need to change your flush buffers to 20 seconds.
It's more than that. It's a combination of your cache size and flush frequency. Like, that's what you have to really look at.
I suggest that you reset to default settings and then use the baseline calculator and then move on from there, install the information component, and gather logs during normal usage and determine what the actual usage should be. But if your flush buffers is 30 minutes, you're going to have a bad time.
Mine, I'm not.
You need to set it to 20 seconds.
I'm setting it lower than 20 seconds.
Okay, cool. Any other questions?
Yeah, quick one. So you mentioned that previously cache was purged by 25%. Now it's 10, right?
Yeah.
So first of all, is there a setting for that?
Good question. Thank you. I did mean to mention that. There is a setting. The default value is now 10%, but there is a set database parameter that tells the exact number of bytes to purge. It's not a percentage if you're going to use the set database parameter. I don't have the number, the selector in front of me, but there is. It's a like cache unload value.
But if you want percentage, we can just calculate, retrieve current cache size. And, yeah. So it's great because like in your example, it was not clear. Okay, so it's purging every 10%. Like why don't make it bigger, right?
Yeah, and that's a really good point because like if you have, let's just say you have a really large system with 200 gigs of cache. Well, 10% is 20 gigs. Like Chuck was saying, Chuck, right? Like Chuck was saying, I mean, if you have a large amount of cache or a large amount of data that's getting flushed or purged, either way, it is going to hurt performance. So, I mean, 200 gigs of cache, 10% being purged, that's 20 gigabytes of data that's in memory that needs to kind of be, quickly calculated. Is this okay to be removed? Is this locked? Can we unlock this? Can we remove that? And it needs to be purged. So if you have a cache size of up to like 200 gigs, you might want to consider using the set database parameter to maybe set it to only unload 1 gigabyte, maybe 2 gigabytes. You could play around with that to figure out which one works best for you without hurting performance. But once you reach that point of a really large cache, you probably wouldn't want to leave it at the default 10%.
Yeah,
so great question.
Last question related to that. During purging, cache purging, what actually happens? Like, does it write to disk or does it just clear the memory?
During automatic cache purging. Okay, so there's two types of automatic cache purging, right? There's the cache purging and then the flush buffers. I'm kind of touched on both. The session was mainly about cache purging that happens automatically when your cache reaches 100%. But I've also mentioned flush buffers, so I just want to be clear on that. The flush buffers default setting since version 12 has been 20 seconds. What that's going to be is that's going to be changes to data. You know, anytime you change a record, anytime you add a record, we're not going to write it to disk right away because writing it to disk is going to be slow. So we put it into memory. And then upon the interval that is set in the database settings, or when you call flush buffers command, or I think it's flush cache now, that's when those changes that have been queued up will be written to disk. So again, the default setting is 20 seconds. It used to be 15 minutes, but 15 minutes worth of changes being flushed to disk is too much because disks are slower. It might be faster with an SSD, but with a spindle-based disk, it's going to be even slower.
If application crashes, like if it's set to 15 minutes and application crashes and then you lose it.
Yeah, exactly. So if your application is set to purge every 15 minutes and it last purged 5 minutes ago, that's, you know, and then it crashes, I mean, that's 5 minutes of the data that hasn't been flushed to disk. So
just a comment on that. If you're doing that, you should be running journal. The way all journals work is that when you write a record, when you save a record, when you change any data, that data gets written physically to the journal. First thing that 4D does, and every database I've ever seen does, is write the journal to disk. So as long as you have a journal file, okay, then it doesn't really matter if your database crashes. Go back to yesterday's packet, integrate the journal, and you're set to go. I mean,
that is absolutely correct.
Right? And you should not be setting your flush settings based on, well, maybe the database is going to crash, so therefore I want to make it a minute as opposed to 30 seconds, or I want to. You don't want to do that. It's the same reason why most snapshots, or every snapshot, simply doesn't work with 4D. I know they said it will in 17 or 18, but it does not work, right? There's been numerous, I know it's kind of off topic, but there have been numerous talks on the NUG about, oh, well, I'm using Time Machine, or I'm taking a snapshot of my database when it's running. You don't have any clue what you get.
The only setting that I'm aware of that works with snapshots in 4D is the volume shadow copy service that is a Windows service, not Time Machine. Time Machine will not work by backing up 4D. But on Windows Server 2012 and higher, there is a volume shadow copy service that 4D version 16R6, I believe, or maybe it was R2. Yeah, it was R2, I think, actually has awareness of that service. So when the virtual machine is usually when this volume shadow copy service is used, when a virtual machine tries to take a snapshot, it tells the volume shadow copy service of the virtual machine, hey, I want to take a snapshot of the whole virtual machine. And what the volume shadow copy service does is it tells the running applications, hey, I need you to do your operations, flush to disk so I can make a snapshot of the files. 4D, prior to 16R2, was unaware of the volume shadow copy service. So we just didn't get that message, and we're just continuing to do our thing. So in that way, when you take the snapshot, it might be in the middle of a flush, which means that the snapshot of 4D is going to be invalid. Moving to 16R2, or I should say to 17, on Windows with virtual machines taking snapshots using the volume shadow copy service, that we are now aware of. And when the application, or when the virtual machine host server says, I'm going to take a snapshot, it communicates into the VM, and 4D flushes to disk. And we suspend any additional writing to disk for a few minutes so that we can make sure that we get a solid, good snapshot. So I'm not sure anything about Time Machine. Time Machine's not using the volume shadow copy service.
It's not just Time Machine, it's other.
Yeah, you need to make sure that you're using the volume shadow copy service in order to do that.
If you have a 200 gig data file, the pin ain't going to fly.
Yeah, the volume shadow copy service actually makes a snapshot on the OS at the file system level. It's instantaneous. It's not an actual copy. So again, Windows versus Mac, they're two completely separate operating systems, and the Time Machine is not really an enterprise class backup system where volume snapshots are something that enterprise IT departments do all the time.